Hello everyone, I'm George Kyriakou, and in this presentation I'm going to demonstrate how to successfully execute a man-in-the-middle attack in a Wi-Fi network using the deauthorization attack, and we will make use of the platform called Pineapple Nano. First of all, a few words about the man-in-the-middle attack. I assume that everybody is already familiar with that. It's a very famous type of attacks and it's applied in many different scenarios. The main point is that we have a malicious user that finds two users, usually a server and a client, and intercepts their communication by relaying their entire traffic. That can have as a consequence that he gains access to all their information that is being transmitted through him. The second attack that we're going to use today, it's called the Authorization Attack. It is mostly used in Wi-Fi networks, and it's actually, let's say, taking advantage of a loophole in the 802.11 protocol. So what happens is that it is a type of denial of service attack and takes advantage of a very specific management packet that is described by the .11 protocol. What happens is it starts sending deauthorization attacks between the Wi-Fi client and access point. Those packets are usually used when we want to deassociate a client from an access point. For example, if the client wants to power off or wants to associate with a different access point. The malicious user, by imitating to be either the client or the access point or both, can send to the other party those packets, effectively terminating their communication. The problem with those packets is that, number one, they are not encrypted, so it is very easy for everyone in the network to see the contents and copy them. And the second part is that they are not considered a request. It is a notification. That means that both the client and the access point have to pretty much listen to those packets and follow the instructions associated with them, which is the deassociation of the two parties. Now, the deauthorization attack is used for many different reasons, in many different ways. The most usual one is to disrupt communication. As we said, what happens is it terminates the communication between the client and the access point. So pretty much it's an annoyance. You have a client connected to the network, suddenly somebody launches such an attack, then you lose your Wi-Fi connection, you have to reconnect, and so forth and so forth. No information is lost or stolen, but of course the disruption of the communication may cost in a lot of frustration and lost time. Now, the second reason those attacks are used is because the client and the access point are getting deassociated. When they get reassociated, they have to go through a handshake. Now, in terms of the WPA and WPA2, the latest standard in the security and the Wi-Fi connections, that means we have a four-way handshake. During that handshake, we exchange the passkey. The passkey, of course, is hashed, but the attacker can actually take those hash values and, through some reverse techniques that we have also covered during the course and some widely available online tools, run some reverse engineering attacks to try and retrieve the password. Of course, this doesn't have a very high percentage of success, but there is a percentage of success whatsoever. Now, the last point, which is also the one that we will cover today, is to actually launch a man-in-the-middle attack. As we said, through that you can get access to a whole lot more information, but of course it's much easier to get detected. Now, there is another one, which we refer to this slide as other funny uses. For example, if you search on the Wikipedia about the deauthorization attack, you will see that at some instances it was used by some hotel chains to force the guests to not being able to associate with their personal hotspots. That way, the guests of that hotel, they had to pay for the Wi-Fi service offered from that hotel, so increasing the revenue of the hotel. Of course, FCC found about that, and they were prosecuted. Now, the platform that we're going to use is called Wi-Fi Pineapple Nano. It's offered by the group Hack5. Many of you may know about that. They have a YouTube channel for many, many years with many interesting products. So in essence, it's a microcontroller equipped with two Atheros Wi-Fi cards, a USB port that you can pretty much plug in any peripheral. A lot of people are using it for a third Wi-Fi card, and a USB port a male one that you can use to connect it to your computer, which pretty much acts as Ethernet over USB, and you can connect to your Nano. Now, the Nano itself runs OpenWRT, which means that it runs open source software, and it is very modular, so you can expand its capabilities very, very easily. And as a matter of fact, the community has many modules that run on the Wi-Fi Pineapple Nano. Now, the goals of this presentation is to execute a successful man-in-the-middle attack, and also at the end show an easy way to detect the attempt. First of all, a little bit about our setup. Now, in the middle of everything is a MacBook Pro. We will refer to that as the controller. It has a wireless interface. We will use that to pretend to be the victim of the entire scenario. This guy will be the one that tries to connect to an access point, then gets kicked out, and then tries to connect to the same one, but it's actually a fake one. We have two USB ports here. One will be used to connect to the Wi-Fi Pineapple Nano. The other one will be used in conjunction with a USB to Ethernet adapter to connect to a different computer that will be acting as a monitor. Now about the monitor, pretty much is another old laptop running Ubuntu 16.10, and on it we have a TLWN722 and a USB Wi-Fi dongle. That Wi-Fi card is actually able to run on monitor mode. It is using the ATH9K driver, and we will be using that to monitor the entire traffic and what is going on the air in order to be able to detect the attack. And of course, the attacker, which is the Wi-Fi Pineapple Nano. As we said, it has two wireless interfaces. We will be using both of those. One will be injecting the traffic in the network, and the other one will be pretending to be the fake access point. Finally, we have the access point itself. Its Linksys WRT54G2 version 1 wireless router. Now, this guy will be running a WPA protected network. The SSID will be testing, just to avoid any confusion. And here you can see the entire experimental setup, along with some of my personal information. I think I have concealed everything that is sensitive. It will be a kind of irony given the course, but if you see something, please let me know. Now it's time for the demonstration. Okay, so the first thing that we have to do is actually set up our access point with an SSID of testing and make it protected. As we said, I have already done that, and you can see it here, testing, and that log signifies that it's password protected. Then the next step would be to allow the victim, in this scenario, this actually the very laptop that we're running the presentation, and through its Wi-Fi interface, we will try and connect to that. I get prompted for a password. So now we can see that I am connected to that network. As a matter of fact, We want to see also some extra information, for example, the IP address that we're given. We see that the security is WPA2 personal. We can see the MAC address, we can see the channel. Channel 3 was selected, so it is not considered one of the non-overlapping channels, which traditionally is 1611. So I can avoid interference from surrounding channels, and I can only isolate the traffic that we're interested in. Okay, continuing, we have to set up the Pineapple. Now for that purpose, we will open our browser. The Wi-Fi Pineapple runs a small web server, and it is accessible and configurable through that. And that is also a very big power of the platform, that it has all that hardware capabilities, but that software that they run and its modular nature make it really, really powerful. Okay, so from here on, we have to see a little bit some of the basic functionality. The most basic and powerful one is the Recon functionality. What that does is, in effect, it scans the entire network and it searches for every possible packet that is through the air. That way we can make a map of what is going on in the Wi-Fi. So we can find all the access points, the clients associated with that, etc., etc. So what we will do here is we will execute that for 30 seconds just to get an essence of what is happening in the surroundings. Now, in the meantime, we have to assume that there is traffic going on in the network, and more specifically, of course, we're interested in the network that we are going to attack. So to that extent, in the meantime, what you do not see in the screen is that I'm actually accessing through the client, the victim, the one that we are talking about right now, the access point. So I'm generating, in effect, some traffic between the two. So the Wi-Fi Pineapple will be able to detect the traffic and see the association between my access point and the victim. Okay, so I see it is at 100%, so it should be done very soon. It runs a small 400 megahertz processor, so it's not the fastest thing around. Maybe if I refresh. No, unfortunately, I will have to do that again. I mean, unfortunately, sometimes this happens. It's not the most stable platform, but certainly for what it offers, it is very powerful. I think, unfortunately, it got a little bit stuck here. Nothing to worry about. Here we have the shell of the Wi-Fi Pineapple. In a normal Linux sense, we can actually reboot it. It is quite quick to reboot, uh, and that way we can also demonstrate it will reset also some of the settings, so we will be able to go through them. Now the Wi-Fi Pineapple, as we said, runs OpenWRT. For those familiar with that, this is considered an open source firmware for various routers, and that gives a lot of flexibility to that hardware. That means we can go into that hardware and start tweaking the drivers. We can start tweaking a lot of things about their functionality, making a router more like a microcontroller that we can very easily access. Now let's see if our Pineapple is back online, and yes it is. So now we will bring our login screen. Okay, now as before, we will attempt to run the recon function for 30 seconds. Hopefully this time we'll have a little bit more luck. As we said, in the meantime, I am generating some traffic on the victim's interface that is currently connected to our network with SSID testing. And hopefully what we expect to see is that Wi-Fi Pineapple will pick up that traffic and will make the association between that access point and that client. So I'm just clicking randomly on the pictures of the thing. I see that the recon finished, and indeed it picked up our testing access point, and we can cross-verify that indeed this is the correct MAC address. And then we can see that it also picked up the MAC address of the victim's interface. Now, what we can do here is we can actually add this MAC address as a filter. This is very useful if uh, want to avoid collateral damage. That means we want to target only that specific guy to either connect to our fake access point or execute a deauthorization attack only towards that MAC address. And of course, we have the tracking capability, which is very important, especially when we're planning the attack, when we want to see to which access points this client associates. And the final thing that we will be looking a little bit later is how to actually execute the deauthorization attack. Now, very quickly, the filters, I have already added 2 users here. That means that only those 2 users will be able to associate with our fake access point. And then in the networking tab, I have deactivated all the access points that the Wi-Fi Pineapple has the ability to operate, just to make sure that we hide our traces as much as possible. Of course, in that scenario, it doesn't really matter. It's just a good measure, let's say. Now we can see that we can, of course, very easily change the MAC address of every interface, so we can do it whatever we want. We can potentially change it to the same as the access point that we want to pretend that we are. Now, probably the most powerful module in the Wi-Fi Pineapple suite is the Pine AP. Now, what we can do here is where we design our Wi-Fi Pineapple to act as an access point. So first of all, we enable the daemon. Then by allowing associations, what we really say is that if a client attempts to connect to that fake access point, we will allow them to. We log the probes and the associations just for a later study to see exactly what happened in the network. We want to enable the beacon response. Pretty much what that means is when the client starts searching for that network, we are going to be the ones that answer to that guy. And finally, we set the intervals to aggressive. So in essence, we're strong arming the real access point. We're also putting as a target MAC address the MAC address of the victim. So we are very specifically targeting that guy with our deauthorization and our probe responses. So we do not confuse any other user in the network, just the one that we are targeting. Now that we have made all the settings, we can go back to the recon module, and then by selecting our client, we can select the deauthorization multiplier. We can go to something very aggressive, and now we could execute the deauthorization attack. Just to be able to see what is going on, I will open up now the monitor. So here I have an SSH connection to the laptop running the other interface in monitor mode. So as we see, I will simply run a tsark running on the interface. As you can see here that I'm running on monitor mode, along with some filters. Pretty much I'm filtering just the deauthorization, the association messages, so we don't see a lot of junk in there. I hope I can get it. I think my connection has broken here. In any case, we can see the result of the deauthorization when I would lose connection. So we can go on for now. So I'll go back to my Wi-Fi Pineapple and I would like security attack. Now I will open up this one and hopefully what we should see is that soon enough I will be deassociated from the testing access point as it just happened. And then I should see another testing popping up, but this time it's one without a lock. Now this is a fake one. Now assuming that the user doesn't notice that lock, he or she would click on that. Now depending on the software version that I'm running on my computer, I may be lucky enough to get a prompt say, okay, testing was previously joined as a WPA and now is open. Are you sure you want to continue? Now if you make the mistake and you click join anyways, now my victim is actually trying to connect to that fake access point, which is the Wi-Fi Pineapple. And it actually managed to do so. Now if we compare what we saw before with now, we can see that we're in a different IP range, we have a different PSSID, and of course we are in a different channel, we have no security. It's a completely different, actually also this one is N, the previous access point was G, everything is different. But if I had connected my Wi-Fi Pineapple to the internet through a third interface, then the user would not be able to tell that something is wrong. He will still have access to the internet, and as far as he or she is concerned, everything would be fine. Of course, from the Wi-Fi Pineapple point of view, we have a client that is connected to us and we can do many different things. Now, from here, it seems that we can only kick it, but actually, if you dig a little deeper, there are a lot of modules there that you can now they need internet access. But for example, we have a module for the SSL split. So literally, with a click of a button, we can deploy an SSL split attack. Now, having seen all that, we want to see how easy it is to detect such an attack from a tool that we made. So let's go to our monitor. So here we will be running what we saw before. Unfortunately, we got cut off, but it's okay. It's up to here. Okay, so now here we will be seeing when somebody is associating or deassociating with channel number 3, because this is the channel that this interface is associated with, which is the channel also that our real testing interface is at. So what I will do now is actually connect to a different access point. And now I can see the real testing back. Why? Because I don't run an attack anymore. So now I'm connected to the real test. And then if I disconnect, I see that actually I received one disassociation packet. And that's it. And that should be the case, that every time that there is a disassociation happening, we only see one packet. On the other hand, if we execute a deauthorization attack, we actually have a tsunami of deassociation and deauthorization packets. Now, to that extent, the only thing that we did was actually redirect all that to a simple script that we wrote. I'm sorry. Okay, so simply running that and then piping that into our script. So what this script is doing is detects when there is such an attempt for a deauthorization, and it raises an alert. So if I go back to my Wi-Fi Pineapple and I go back to Recon, and then let's say that I connect back to my testing. I want to remember it. Okay, now I am connected to my testing. Now let's assume that I'm executing again a deauthorization attack to that guy. So what I'm looking now in the script is whether I see a high concentration of deauthorization packets between two specific MAC addresses in a very small time window. If those three conditions are met, then an alert is raised to the user and says, okay, most probably you are under attack, so you better be careful or take specific precautions. Now we launched the attack, and indeed we saw that we did lose connection, and now it would connect to whatever we want or whatever we have said before. But what we're really interested is what has happened to our filter here. We can see that our script is going crazy, that hey, there was an attack detected, and actually has flooded the network because we selected 10 so much that I have flooded the output with attack detected. So I think this concludes our demo. Going back to our presentation. So what we have seen is that the deauthorization attack is an extremely easy attack to execute. There are many software tools like the Wi-Fi jammer on GitHub. It's through Python. Of course, we have Aircrack NG. The tools have been around for so many years, and platforms like the ones that we use here, like the Wi-Fi Pineapple. Setting a fake access point is also quite easy, either with Wi-Fi Pineapple or other similar tools. Now some other ones are even more sophisticated, like the Wi-Fi Fisher, and instead of pretending to be just the same access point, they also pop up a fake web page that prompts the user to insert their password, also getting the password. Now, the only solution that there is out there for that kind of attack, for the deauthorization attack, is described in the .11w protocol, which pretty much protects also those management frames. Unfortunately, that protocol is not followed widely. It's only followed by very specific equipment. So everybody at this point is susceptible to this attack. And since prevention is almost impossible, incorporating a simple detection tool like the one that we presented here is highly recommended. Some references that you might be interested in, and I think that's it. Thank you for your time, and I hope you found the presentation interesting. Bye.